A supervolcano is any volcano capable of producing a volcanic eruption with an ejecta volume greater than 1000 km3. This is thousands of times larger than normal volcanic eruptions. Supervolcanoes can occur when magma in the mantle rises into the crust from a hotspot but is unable to break through the crust, and pressure builds in a large and growing magma pool until the crust is unable to contain the pressure. They can also form at convergent plate boundaries. Although there are only a handful of Quaternary supervolcanoes, supervolcanic eruptions typically cover huge areas with lava and volcanic ash and cause a long-lasting change to weather sufficient to threaten species with extinction. Terminology: the origin of the term supervolcano is linked to an early 20th century scientific debate about the geological history and features of the Three Sisters volcanic region of Oregon, United States. In 1925, Edwin T. Hodge suggested that a very large volcano, which he named Mount Multnomah, had existed in that region. He believed that several peaks in the Three Sisters area are the remnants left after Mount Multnomah had been largely destroyed by violent volcanic explosions, similar to Mount Mazama. In 1948, the possible existence of Mount Multnomah was ignored by volcanologist Howell Williams in his book The Ancient Volcanoes of Oregon. The book was reviewed in 1949 by another volcano scientist, F. M. Byers, Jr. In the review, Byers refers to Mount Multnomah as a supervolcano. Although Hodge's suggestion that Mount Multnomah is a supervolcano was rejected long ago, the term supervolcano was popularized by the BBC popular science television program Horizon in 2000 to refer to eruptions that produce extremely large amounts of ejecta. Volcanologists and geologists do not refer to supervolcanoes in their scientific work, since this is a blanket term that can be applied to a number of different geological conditions. Since 2000, however, the term has been used by professionals when presenting to the public. The term megacaldera is sometimes used for caldera supervolcanoes, such as the Blake River megacaldera complex in the Abitibi Greenstone Belt of Ontario and Quebec, Canada. Eruptions that rate VEI8 are termed super-eruptions. Though there is no well-defined minimum explosive size for a supervolcano, there are at least two types of volcanic eruption that have been identified as supervolcanoes: large igneous provinces and massive eruptions. Large igneous provinces. Large igneous provinces such as Iceland, the Siberian Traps, Deccan Traps, and the Java Plateau are extensive regions of basalts on a continental scale resulting from flood basalt eruptions. When created, these regions often occupy several thousand square kilometers and have volumes on the order of millions of cubic kilometers. In most cases, the lavas are normally laid down over several million years. They release large amounts of gases. The Ra Copyright Union hotspot produced the Deccan Traps about 66 million years ago, coincident with the Cretaceous-Euro-Paleogene extinction event. The scientific consensus is that a meteor impact was the cause of the extinction event, but the volcanic activity may have caused environmental stresses on extant species up to the Cretaceous-Euro-Paleogene boundary. Additionally, the largest flood basalt event occurred around 250 million years ago and was coincident with the largest mass extinction in history, the Permiana-Euro-Triassic extinction event, although it is also unknown whether it was completely responsible for the extinction event. Such outpourings are not explosive, though fire fountains may occur. Many volcanologists consider that Iceland may be a LIP that is currently being formed. The last major outpouring occurred in 1783-84 from the Lake Fissure, which is approximately 40 km long. An estimated 14 km3 of basaltic lava was poured out during the eruption. The Java Plateau now has an area of about 2 million km2, and the province was at least 50% larger before the Miniiki and Ikurangi plateaus broke away. Massive explosive eruptions. Volcanic eruptions are classified using the Volcanic Explosivity Index, or VEI. VEI Euro-8 eruptions are colossal events that throw out at least 1,000 km3 dense rock equivalent of ejecta. VEI Euro-7 events eject at least 100 cubic kilometers DRE. VEI or Euro 7 or 8 eruptions are so powerful that they often form circular calderas rather than cones because the downward withdrawal of magma causes the overlying mass to collapse and fill the void magma chamber beneath. One of the classic calderas is at Glencoe in the Grampian Mountains of Scotland. First described by Clough et al. Its geology and volcanic succession have recently been reanalyzed in the light of new discoveries. There is an accompanying 125,000 solid geology map. By way of comparison, the 1980 Mount St. Helens eruption was a VEI 5 with 1.2 km3 of ejecta. Both Mount Pinatubo in 1991 and Krakatoa in 1883 were VEI 6 with 10 and 25 km3 DRE, respectively. The death toll recorded by the Dutch authorities in 1883 was 36,417. Although some sources put the estimate at more than 120,000 deaths. Known super-eruptions: VEI 8, VEI 7, VEI 7 volcanic events, less colossal but still supermassive, have occurred in the geological past. The only ones in historic times are Tambora, in 1815, Lake Taupo, Haitup, around 180 CE, and possibly Baekht Mountain, 969 CE plus or minus 20 years, and the Minoan eruption of Santorini. Ongoing studies: a hypothetical Campanian bright super-eruption around 40,000 years ago has been suggested as having contributed to the demise of the Neanderthal, based on evidence from Mezmayskaya Cave in the Caucasus Mountains of southern Russia. A diamond anvil cell simulation at the European Synchrotron Radiation Facility and computer modeling at the University of Bristol showed that it was possible for a supervolcano eruption to occur simply through the slow addition of liquid magma without any external trigger such as an earthquake that might provide warning of the event. Media portrayal. In 2004, Naked Science TV show aired Supervolcano on National Geographic Channel. In 2005, a two-part television docudrama called Supervolcano aired on BBC One, the Discovery Channel, and other television networks worldwide. Nova featured an episode Mystery of the Megavolcano in September 2006 examining such eruptions in the last 100,000 years. In 2006, the Sci-Fi Channel aired the documentary Countdown to Doomsday, which featured a segment called Supervolcano. The same year, ABC News aired the documentary Last Days on Earth, which featured a segment called Supervolcano. Also in 2006, the Sci-Fi Channel series Stargate Atlantis episode entitled Inferno featured a supervolcano as the major plot device. Dr. Rodney McKay, one of the main characters, uses Yellowstone National Park to describe what a supervolcano is. In the episode Humanity of the television drama Young Justice, the team must relieve the pressure of the Yellowstone Caldera supervolcano caused by Red Volcano before an eruption with the potential for mass extinction takes place. In 2009, the Apocalypse-themed film 2012 featured the super-eruption of the massive Yellowstone Caldera, a result of the Earth's core heating up. This made most of the United States uninhabitable. In 2010, the sci-fi series Warehouse 13 featured an episode entitled Reset in which a supervolcano, specifically the Yellowstone Caldera, plays an important role. In December 2011, author Harry Turtledove published Supervolcano, Eruption, the first of a planned 4-novel series about events leading up to and following a fictional eruption of the Yellowstone Caldera. The second book in the series, Supervolcano, All Fall Down, was published in December 2012. The third book Supervolcano, Things Fall Apart, was published in December 2013. The last volume Supervolcano, Maelstrom is scheduled for 2014. At the end of Terry Pratchett and Stephen Baxter's novel Long War, the Yellowstone Caldera erupts. The aftermath will be featured in the next volume, Long Mars. See also: Risks to Civilization, Humans, and Planet Earth, Toba Catastrophe Theory, Timetable of Major Worldwide Volcanic Eruptions, References. Further reading: Mason, Ben G. Pyle, David M. Oppenheimer, Clive. The Size and Frequency of the Largest Explosive Eruptions on Earth. Bulletin of Volcanology 66, 735 Euro 748. Bibcode 2004 BVOL 66735 MDOI 10.1007 per second 00445-004-0355-9. Oppenheimer, see Eruptions that Shook the World. Cambridge University Press. ISBN A978-0-521-64112-8. Timrek, C. Graph, HF. The initial dispersal and radiative forcing of a Northern Hemisphere mid-latitude supervolcano, a model study. Atmospheric Chemistry and Physics 6, 35 €49 doi, 10.5194/ACP6-35-2006. External links, overview and transcript of the original BBC programme, Yellowstone's supervolcano and map of supervolcanoes around the world, USGS fact sheet Steam explosions, earthquakes, and volcanic eruptions Watson Yellowstone's future. Scientific Americans: The Secrets of Supervolcanoes, Supervolcano Eruption Mystery Solved, BBC Science, January 6, 2014.